This week, we will talk about object-oriented programming in Python. Object-oriented programming can be viewed as a whole course on its own. Therefore, our approach cannot be exhaustive. We will talk about the main points of object-oriented programming and show basic examples of using it in Python. In this video, we will talk generally about object-oriented programming and Python. We will define classes and objects and see how to create them in Python. You may be familiar with the object-oriented programming paradigm, either as an abstract concept or through your experience with some other object-oriented programming language. I will, however, assume no knowledge on the subject. Therefore, let me start by saying that object-oriented programming is a programming paradigm that is based on objects. It allows us to define our own types for organizing data, also known as classes. You may know Java or C++ as popular object-oriented programming languages. Python also supports object-oriented programming. By many, is even considered a clear-cut object-oriented programming language. Now, in this course, we view Python as a tool for data science. In that sense, object-oriented programming is not really necessary. You can very well do data science and use Python, the functionalities we have seen so far, and the ones we will see in the upcoming weeks, without using or even knowing about object-oriented programming. It is even a silent truth that many researchers and data scientists might spend their whole lives without using object-oriented programming. I, for one, haven't used it so far in my research work, and my code works as fine. However, I believe that a programmer and a data scientist alike should be, at the very minimum, familiar with it. It is always likely that its need will arise at some point in the course of your work, or that you will need to understand and interpret code written in object-oriented programming. So without further ado, let's talk about object-oriented programming in Python. In object-oriented programming, we spoke in terms of classes and objects. A class is a programmer-defined type that represents a collection of objects. As a naive example from everyday life, consider the class cars, which includes every car ever manufactured. A class offers a blueprint for an object that is a member of that class, which describes its attributes or variables and its behaviors or functions. Going back to the car example, the attributes of a car object could be its brand name, its color, its engine capacity, its production year, whereas certain behaviors or functionalities is whether it contains an internal navigation system, whether it supports self-driving functions, etc. An object, then, we say, is an instance of a class. In the car example, a red Renault Clio IV of the year 2008 would be an instance of the class cars. An object consists of a name variable, which represents the object. It consists of data or properties that describe the object and methods that describe the object's behavior. To create a class in Python, you can simply type the keyword class and then the name you want to give to your class, then colon so anything in the class is intended. There you can create variables and methods for the class. Let's see an example here. I create a class called point, which is to represent a point in a two-dimensional space. So far my code would have nothing. It's just a header with the name of the class. No functionality, no methods, no attributes. If you call the name of the class, if you just type it and press enter, that is, then you will see that it is a class object. Now, notice that if you run this on your terminal or on your Jupyter notebook, you might see the object definition here returned differently. So don't be alarmed, it's just a different way of saying exactly the same thing. And then if you attempt to check the type of the class, as we have used before for other objects, you will see that it is a class type. No particular interest here. Now you have created an empty or dummy class. How can you create a new object of that class? This is also known as instantiating a new object. So here we have the class we defined. To create a new object, we can just create a variable, give it the name that we want for the new object, and then assign it to a call to the point class with an empty parenthesis for now. So we just type the name we want to give our object, the name of the variable that represents the object, and then point, which is the name of the class, and an empty parenthesis for now. This creates an object of the point class. So if you check what a point is now, you will get this message, which means that it is an object of the point class. This part of the message here, it just tells you where in memory this object is stored. Let us see all that in Jupyter now. I will create a class point. And in here, I'm not going to offer any properties, attributes, or methods right now. We haven't seen how to do that yet. I'll just write a comment. This is a class that represents a point in two-dimensional space. Okay, so let's just call point. You see the message I get, it is that it is a class, but it looks different from what I showed you in theory because here I ran it on a notebook, whereas the message I showed you in theory, it's from my terminal. So don't be alarmed. And you can check also the type of point. It doesn't give you the result I gave you earlier, but if you type this same thing in your terminal instead of notebook, you will receive that it is type class. So now let's create a new object. I'll create an object called a point of the point class. So I just type a point is the name I want to give to my object equals point, which is the name of the class, and an empty parenthesis for now, because we haven't seen how can we use the parenthesis. So now if I check what is in a point, I receive that it is a point class, a point object, sorry, and it is found in that particular part of the memory. It is stored there, and I can create more points. B point is another object of the point class, but it is different from A point, and it is found in a different space in memory. A useful thing to know is the built-in function isInstance, which is used when we wish to know whether an object is an instance of a class. Given, for example, the class point that we created and an object of that class, A, for example, we can call isInstance. First argument we give the object, and the second argument we give a class, and this command, this function, returns true if the object is an instance of the class. Let us see this in isInstance built-in function here. So we have 2 points, 2 objects, A point and B point. If I call isInstance A point, first I give the object or value that I'm wondering if it is an object, and then the name of the class, and that should return true. Same for B point and point, that should also give me true. Now let us assume that there is somewhere in your code a variable. Let's assume that this variable is called A and it is a string variable containing the string hello, and you're wondering if A is an object of the point class or something else. So let's see if we check A point, then that is false. So this is an instance where the object that we give in the instance to check against a class, if it's an instance of that class, is not true. To recap now, object-oriented programming is useful to know, and in many instances it is the suitable paradigm to apply for an application, even though it is not strictly necessary for data science, all depending though on the application, of course. We spoke about classes and objects and how to create those, and lastly we mentioned the built-in function isInstance that allows us to confirm whether an object is an instance of a certain class. See you in the next video.